Hello dear student, welcome to my class. Last class we discussed applications of dimensional analysis. We already discussed how to check a given relation is correct or not by using the principle of homogeneity, and second we derive a relation by using using various physical quantity. Clear? That means we discuss first use of dimension and second use of dimension. Now we will discuss here third use of dimension, and the third use of dimension is known as, we already know what is MK system and CGS system. There is two system, MKS meter kilogram second, and then there another system CGS system. So we have to convert a physical quantity SI system to MK system to CGS system and CGS system to MK system. That means here we deals with the third use of dimension, that is conversion of a unit. Conversion of unit from one system to other system. MK system to CGS system or CGS system to MK system. Clear? So here we deals with conversion of unit from one system to another system. Clear? Okay. Now, so first we have to know just theory about how to convert a unit or how to convert a physical quantity SI system or MK system to CGS system. Suppose we already have a relation that suppose there is a physical quantity X, and this physical quantity can be represented in terms of suppose here we can write that is 2 kg in MK system, and here 2 kg means it is mass, and mass is here physical quantity and this mass is a constant quantity, or you can write 2 kg which is equal to, or you can write here suppose if we will take length which is equal to 2 meter. This is in MK system which is equal to 2 meter, or you can write this unit in that is 200 centimeter in CGS system. Clear? So here unit change meter to centimeter and also numerical value change 2 to 200, but the physical quantity length, here length also constant. Similarly you can write 2 kg equal to 2000 gram in this way. Clear? So first there is a physical quantity X, and this X can be write, we already have relation that is N1 U1 and which is equal to N2 U2. So what is N1 U1? Here N1 numerical value, N1 and N2 are numerical value in system 1 and system 2. Suppose this is system 1 and this is system 2. Here system 1 MK system and system 2 here CGS system. Clear? Similarly another one unit, what is U1? U1 and U2 are unit of the physical quantity in first system, and we can write that is second system. First system means here MK system and second system means here CGS system. But what is X? X is here physical quantity, and this physical quantity is constant. It's constant for both system, MK system or CGS system. Clear? Okay. Now we can write here M1, next L1 and T1. M1, L1, T1 be the size of fundamental unit. M1, L1, T1 be the size of fundamental unit, or you can write in first system in first system. Similarly, M2 L2 T2, M2 L2 T2 be the size of fundamental unit which is in that is second system. Clear? Okay, but here the physical quantity remain constant, so we can write this physical quantity, we can write here, and there is another term that is q. Q means here, sorry, u means unit. So the dimensional formula of the quantity here x, so we can write, so the dimensional formula of the physical quantity x, and it can be write that is m a l b and t c. So what is a b c? A b c is your dimension in terms of length, mass and time. So where we can write here, where a b and c are the dimension of x, in terms of mass, length and time. Clear? So there is another unit here, u1 in first system and here u2 in second system. So same way you can write u1 means unit in first system, because this is system number 1, or we can write here first system, this is unit, and that unit which can express in the basic quantity, and here mass, length, time. So you can write u1 which is equal to t1, and sorry, first we can write m1, next l1 and t1. Clear? m1, l1, t1, or we have to find here dimension a, b, c, but here physical quantity remain constant. Similarly, you can write u2 means second system, and its unit can be expressed in mass, length, time, but it's second system, so you can write m2, l2, t2, and here dimension a, b, c. Clear? Now use this value u1 and u2. This is first system and this system where physical quantity remain constant, but its unit change. While you are coming from MKS to CGS system, then numerical value change and its unit also change, and CGS to MKS system also numerical value change and unit change. So that's why you can write here x equal to we have n1 u1 which is equal to n to u2. Here physical quantity constant, so you can write n1 u1. What is u1? u1 is here, we can write m1 power a, l1 power b and t1 power c, similar, which is equal to n2 numerical value and u2 its unit. So m2, l2 and t2 this relation. Clear? But here we have to find system of unit, but basically we have to know some idea about how to convert system of unit. That means we have to find numerical value in second system. Here first system numerical value 2, but we have to find numerical value in second system. So but physical quantity remain constant, so that's why you can write here so here we have relation n1 m1 n1 into m1a l1b t1c n2 equal to m2a l2b t2c. Okay, so if you want to find, suppose n2, this is n2, you can write here n1 u1, here n2 u2, but you have to find n2. So how can we find n2? Here n2 we can write n2 or n1. First we have to find n1 which is equal to this term divide here, then we can write n2 m2a l2b and t2c divided by m1a l1b t1c. Clear? Okay, but here the power from a and mass of there m1 and m2 power equal L1 L2 and T1 T2 whose power equal. So we can write this term N2 into, here we can write M2 by M1, M2 by M1, its power A. Similarly you can write here it is L2 by L1 power B and T2 by T1 power C. In this way we can calculate the value of N1. Clear? So this is the theory how to find numerical value in second system. Similarly you can find the value of N2, and N2 is here. So this quantity, now divide this side we can write. So N1 here M1A, L1B and T1C, which is divided by here this term M2, M2A, L2B, T2C. Clear? So we can write N1 into M1 M2, M1 by M2 power A, L1 by L2 power B and T1 by T2 power C. Clear? So you have to remember these two relations to find numerical value of a physical quantity in first system and system number 2, first and second system. Clear? Okay. By using these two formula, we have to convert a numerical value and a physical quantity first system to second system. Clear? Okay. Suppose question number 1, now let's start how to convert by using this formula. Convert 1 joule of work into another system, or question may arise in arc. Convert 1 joule of work into arc. So you have to know what is joule. Joule means first we have to find here the what is physical quantity here. So given that 1 joule, and joule is the unit of energy, and here also given 1 joule of work is here physical quantity. So first you have to identify what is the physical quantity in given relation or given question. So here come to solution part. Here physical quantity work, and we already know the dimensional formula of work M1 L2 T minus 2. Clear? And here the power M1 L2 T minus 2, we can write A B C. This is power format. So we can write here A equal to 1, B equal to 2 and C equal to minus 2. A B C. Next will come system number 1. System 1, and here system 2. Here we have to convert 1 joule of work, means 1 joule of work which is equal to dash or. This is our question. And here N1 U1 equal to N2 U2. But here U1 is joule and U2 is erg. But joule in MK system or SI system, but we already know the CGS unit of work which is equal to joule. So you can write this is CGS system. So this is system number 1, this is system number 2. But given that N1 equal to 1, but we have to find N2 numerical value in CGS system. So you can write here this is MK system. System number 1 is your MK system, and second this is CGS system or second system number 2. Clear? Okay. Now it is given that N1 which is equal to 1. So you can write here N1 equal to 1, and again we have a relation. What is that relation? How to calculate N2? Because N2 equal to N1, we already derived relation M1 by M2 power A, and here L1 by L2 power B and T1 by T2 power C, power here C. If you want to find N2, then here N1 means here M1, L1, T1. You have to remember in this way, N2 equal to N1, and you have to first write here M1 n1 m1, clear? Then we can write in this way. So suppose you have to write here n1, then here n2 means first you have to write m2 by m1, then you can write in this way, clear? So this is the format how to remember this equation. So n1 equal to, given that n1 equal to 1, now to find m1 l1 t1. What is m1 l1 t1? m1 l1 t1 is the size of dimension or size of fundamental unit in first system. So this is first system, system number 1. So you can write here m1 l1 and t1, which is equal to, clear? But in second system we can find n2, then we have to find here m2 l2 and t2. Okay, now come to the concept here. Work which is equal to force into here displacement, clear? We have to find the unit of work which is equal to joule. So here we can write that is joule equal to here Newton, or we can write Newton means force equal to mass into acceleration, clear? This is mass into acceleration, or we can write here force which is equal to, or mass we can write mass into acceleration into displacement s. Then we can write here mass, we can use here kg, acceleration meter per second square into second, clear? Kg meter per second square into second. 1 second cancel, the remaining part we can write here kg meter per second, kg meter per second, clear? This is the unit of joule. So here joule, but we already know what is rational system of unit. Rational system of unit means if you want to find 1 joule, 1 watt, then we have to use the another term which is the form of 1 format. That means if you find to here 1 joule, then kg will be 1 kg, mass will be 1 meter, time will be 1 second. All the quantities, mass, length, time, or all the fundamental quantity, we have to use here only one quantity, and then we get 1 joule of work, and this is known as rational system of unit. Similarly, if you want to find power equal to work by time, so power, the unit of power which is equal to watt, but you want to find or you want to evaluate the value of 1 watt. So if you write here 1 watt, then we have to write 1 joule. Here work unit joule, so joule per second, then 1 watt definition which is equal to, there must be 1 joule divided by 1 second which is equal to 1 watt, clear? So this is the general condition, and this is known as rational system of unit. So we have to use here n1 equal to 1. What is mass? When there is given joule, then we have to use here mass equal to 1 kilogram. Mass equal to 1 kilogram. Here 1 kg mk system, clear? If you given 1 joule, then you can write 1 kg. Here mk system 1 kg, L1 equal to 1 meter, time equal to 1 second is given 1 joule of work. And again here identify org means CGS system. So CGS system we can write here org, this joule converted to org, that means 1 org. Here kg converted to gram, 1 gram, meter converted to centimeter, 1 centimeter, second converted to 1 second. So you have to write this relation for 1 org. So you can write here m2 equal to, but we have to find n2. So m2 which is equal to here 1 gram means second system. So we can write here 1 gram CGS system, next 1 centimeter, then 1 second. Now use this value in this given relation. So if you use this relation, use the value in this relation n2 here, then we get the conversion of unit from one system to another system, clear? So here n2 equal to n1, n1 means here m1, m1 by m2 power a, L1 by L2 power b, T1 by T2 power C. Now use value here. So N2, N1 is your 1, M1 is your 1 kg, 1 kg divided by M2 is your 1 gram. M2 is 1 gram, and again L1 1 meter, sorry, power A, and A is given, A power A is given here 1, so you can write here 1 meter divided by 1 centimeter, here L2 1 centimeter, and power B is equal to here 2, and then T1 by T2, T1 is here 1 second, so 1 second divided by 1 second, power is here minus 2. Clear? Now solve this equation. So here 1 into 1 kg, you can convert kg into gram or gram into kg, one system of unit. So you can write 1 kg which is equal to 1000 gram divided by 1 gram, or you can convert this kg into gram. Clear? So 1 gram whose power 1 meter, you can write 100 centimeter divided by 1 centimeter, and it is power 2, and 1 second cancel, and power minus 2. So you can write here gram cancel, and centimeter also cancel, then here 10 to the power 3 power 1 into here 10 square, and it's power 1, but here this is minus 1 2 times, minus 1 into minus 1, and here minus positive, 1 is equal to 1, so you can write here 1. So here 10 to the power 3 into here 10 to the power 4, so the value of N2 which is equal to 10 to the power minus, 10 to the power 7, but here we can write 1 joule of work which is equal to dash, or we have to write here N2 which is equal to 10 to the power 7 arc. Clear? So this is the conversion of unit, and here question conversion of unit from, convert 1 joule of work into arc. So 1 joule of work which is equal to 10 to the power 7 arc. Clear? So there is another one question, convert 1 Newton into dyne. Convert 1 Newton into dyne, or convert 1 Newton of force into CGS system. Clear? So in this case, here given 1 Newton into dyne, so you have to convert here 1 Newton which is equal to dash dyne, and this is given that this is MK system, and this is here this CGS system of unit. So first we have to find what is physical quantity here. So physical quantity here, physical quantity which is equal to force, because we already know the unit of force which is equal to Newton, so we can write here force, and its dimension first we have to write M1 L1 T minus 2, and here A equal to 1, B equal to 1, and here C equal to minus 2, A, B, C. Clear? Next we have to write here system number 1, and again there is system number 2, system 2, and here system 1, this is Newton for MK system, and system 1 MK system, and system 2 dyne, here CGS system, and given that N1, here N1 equal to 1, but we have to calculate N2. Clear? So here given that N1 equal to 1, and we have to calculate N2, and again same thing M1 L1 T1. Clear? If there is given Newton, then you can directly write M1 equal to 1 kg, L1 equal to 1 meter, T1 equal to 1 second, because Newton also rational system of unit. So next we can write here M2, L2 and T2. M2 we can write here 1 gram, because dyne we already know this is rational system of units, so we have to use 1 gram, 1 centimeter, 1 second. Now we have to find N2. N2 equal to N1, M1 by M2 power A, L1 by L2 power B, and T1 by T2 power C. Now use value here N1 which is equal to 1, and M1 is your 1 kg divided by M2 1 gram, and power 1 here, then L1 1 meter divided by 1 centimeter, and here power B is equal to 1, and 1 second divided by 1 second, here power minus 2. Clear? So we can write here 1 into 1 kg 1000 gram divided by here 1 gram. You have to convert kg, you have to convert gram into kg or kg into gram, but power is here 1. Similarly 1 meter, you can write 100 centimeter divided by 1 centimeter and your power 1, and second cancel 1 minus 2. Now gram, here centimeter cancel, only the remaining terms here 10 to the power 2, and here 1, this is 1000, so we can write 10 to the power 3, and the remaining term 10 to the power 5, which is get N2, numerical value of N2. So here we can write 1 Newton, which is equal to 10 to the power 5, 10 to the power 5 dyne. Clear? Question number 3. Convert 10 arc into MK system or SI system. Question: convert 10 arc into SI system. That means we have to convert here 10 arc dash joule, because in SI system the unit of arc which is equal to joule, but given that here N1 equal to 10 and here U1, but here we have to find N2 and here U2, we have to find here first N2. So first we have to identify here arc is CGS system and joule is here SI system, or we can write MK system, because MK system is equal to SI system. So first we have to find here what is physical quantity here, because here joule and this is arc, so here the physical quantity is work. So here physical quantity work and its dimension you already know, M1 L2 T minus 2 its dimension. So A equal to 1, B equal to 2, C equal to minus 2. Then you have to write system 1 and system 2. Here system 1 is CGS system, so here write you have to, that is CGS system, and you can write here MK system 2. Clear? Okay, here N1, and given that is 10, N1 which is equal to 10, but we have to find N2 equal to dash. So we have to first write M1, L1 and T1, and similarly we have to write here M2, L2 and T2. So what is M1, L1, T1? We cannot write here 1 kg because this is fast system, but here CGS system. In CGS system we have to write 1 gram, 1 centimeter, 1 second. But in MK system we can write 1 kg, 1 meter, 1 second. So this is CGS system, we can write here 1 gram, because org and joule is rational system of unit, so we have to use 1. So 1 gram, 1 centimeter, 1 second, and here we can write 1 kg, because this is SI system and MK system. L2 equal to 1 meter, and here 1 second. Similarly you can find N2 equal to N1, M1 by M2 power A, L1 by L2 power B, and here it is T1 by T2 power C. Now use value here 10 into M1 by M2. M1 is here 1 gram, so you can write here 1 gram divided by M2 1 kg, so you can write here 1 kg power here A equal to 1, and similarly L2 here L1 by L2 1 centimeter divided by 1 meter, and power B is here 2. Same way you can write 1 second or T1 1 second divided by 1 second, and here power minus 2. So then we can write 10 into here 1 gram, you have to convert it gram into kg or kilogram into gram. So we can write here 1 gram divided by 1 kg, or you can write here 1000 gram power 1. Similarly 1 centimeter divided by 100 centimeter, 1 meter equal to 100 centimeter, but power 2. Same way you can write 1 second cancel and minus 1. Here gram, centimeter cancel, and 10 into here 1 by 100, so you can write 10 to the power minus 3. Here 10 to the power 3, if you take numerator this quantity, then it will be 10 to the power minus 3, and again here 10 to the power 2 and here 4. So you can write here 10 to the power 4. 10 to the power 4 into 1, because minus 1 into minus 1 which is equal to plus 1, and here we get 10 into 10 to the power 3 minus 3, and here 10 to the power minus 4, which is equal to 10 into 10 to the power minus 7, 10 to the power minus 7, and here 1. So finally we get 10 to the power minus 6. Clear? So we can write here 10 arc which is equal to 10 arc which is equal to 10 to the power minus 6 joule. Clear? So in this way you can find different type of physical quantity, convert one system of unit to another system of unit. Now let's start another question. The value G in CGS system which is given by 6.67 into 10 to the power minus 8 dyne centimeter square gram minus 2. Calculate the value of G in SI system. G means universal gravitational constant. G we already discussed. So here physical quantity. First you have to identify physical quantity. What is physical quantity here? So physical quantity here, that is gravitational constant. Universal gravitational constant G, and its value given that 6.67 into 10 to the power minus 8, and here given that dyne centimeter square and gram minus 2. But first we have to find dimension of G, and its dimension MLT M1 L3 T minus 2, sorry, M minus 1. You have to find first dimension of G. Clear? Okay. We already have a dimension formula of G, that is M minus 1 L3 T minus 2, and here we can write A equal to minus 1, and B is here 3, and C is here minus 2. Now we have to write system number 1, here system 1 and system 2. System 2. In system 1, here dyne centimeter square gram, this is CGS system. CGS means here N1 U1 equal to N2 U2. Here unit in CGS system, this is fast system, but we have to find this is MK system. We have to find MK system, but given here CGS system. So fast system we have to take here CGS, MKs or SI, and given N1 equal to 6.67 into 10 to the power minus 8 N1. Similarly you can write M1 L1 T1, and again here N2 you have to find its value M2 L2 and then T2. Clear? Okay. So what is CGS system and how can we write the dyne centimeter gram? We already know for rational system of unit we have to write 1 1 1. So here we can write 1 gram, 1 centimeter, 1 second. But this is MK system, 1 kg, 1 meter, 1 second. Directly you can write formula N1 M1 by M2 its power A, L1 by L2 its power B, and T1 by T2 its power C. So here N1 and its value N1 is here 6.67 into 10 to the power minus 8 M1 is here 1 gram. So you can write 1 gram divided by M2 1 kg divided by power 1 is here minus 1 into L1 by L2. L1 is here 1 centimeter, 1 centimeter by 1 meter, and it is power 3, and again 1 second time 1 second by 1 second, and power is here we can write here minus 2. Clear? Now solve this relation here. So we get 6.67 into 10 to the power minus 8. 1 gram we can write 1 gram, then 1 kg which is equal to 1000 gram. What power is here minus 1, and again 1 centimeter divided by 100 centimeter, and it is power 3, and 1 second cancel, and 1 minus 2. Clear? And here 6.67 into 10 to the power minus 8, gram cancel, here 10 to the power 3, so you can write 10 to the power minus 3, and here also minus 1, and again if you multiply gram cancel, sorry centimeter cancel, and its value 10 to the power minus 2, and here 3. into 1. Now solve this relation. So 6.67 into 10 to the power minus 8, and here if you multiply, then 10 to the power plus 3. 10 minus minus plus, 3 1 ja 3. 10 to the power 3 into here 10 to the power 2 3 ja 6, but minus 6 is here. So this relation turned to be here 6.67 into 10 to the power minus 8, here minus 8, here minus 6. So you can write like 8 plus 6, 14. So 10 to the power minus 14 into here 10 to the power 3, 10 to the power 3, or you can write this value here. So n2 equal to 6.67 into 10 to the power minus 14 plus 3, here 10 to the power minus 11. This is the numerical value. Clear? So we get the numerical value which is equal to 6.67 into 10 to the power minus 11. But here given that, so we can write in SI system its value, we can write the value of gravitational constant G in SI system or MK system, which is equal to 6.67, because this is numerical value, into 10 to the power minus 11. But you have to write unit here. So its unit here dyne, so you can write here Newton. Centimeter we can write meter. Gram we can write kg. Newton meter kg. So we can write here Newton meter square kg minus 2. Clear? So this is the unit of gravitational constant in SI system. So next, come to that question. This is an important question, and how to solve this important question, listen carefully. Find the value of 60 joule per minute. Find the value of 60 joule per minute on a system has 100 gram, 100 centimeter, and 1 unit. 1 second is here. 1 second as the base unit. Clear? So here don't identify which type of system, and that system whose base unit 100 gram, 100 centimeter and 1 second. Because we already know if that is 1 gram, 1 centimeter, 1 second given, then this is CGS system. Or 1 kg, 1 meter, 1 second, this is MK system. But we don't have any idea about 100 gram, 100 centimeter and 1 second. And here this unit or this system is another type of new system, we call new system. And whole system is basic quantity here 100 gram, like here 1 gram, and that system of unit here 100 gram. Similarly here 1 second, here 100 second, and 1 second is here, and here 1 second. But this is CGS, this is MKS, but this is base unit of new system. This is a new system of unit. So first we have to find physical quantity here. So what is physical quantity here? Joule, 60 joule per second. 60 joule per second. So what is the physical quantity here? And which physical quantity possesses this type of unit? No, there is no quantity which possesses this type of unit, but we already know 1 watt, which is equal to 1 joule per 1 second here. But here given that 1 minute here. Given that 1 minute. This is not the unit of watt, but unit of what? 1 joule per 1 second. But here 1 minute. So we have to convert it 60 into here a joule per second. We have to convert minute into second. So here 60 second. 60 cancel. So here physical quantity. So physical quantity here we get 1 into here a joule per second. So joule per second, which is equal to 1 watt. That is 1 watt. Now we find the physical quantity here. So physical quantity here power, because 1 watt is the unit of power. So we have to write here the unit of power, which is equal to watt. So first we have to find dimension of power. So dimension of power, which is equal to power equal to work by time. Work by time means here time minus 3. So you can write power m1, sorry, unit m1 L2 t minus 3. This is dimension. Dimension is important to convert one unit. So here A equal to 1, B equal to 2 and C equal to minus 3. But what is here power and this unit joule? But joule is MK system, and in MK system the base unit 1 kg, 1 meter, 1 second. So we can write here system number 1 and here that is system number 2, clear. And this system number 1 given that here MK system, because what 1 joule per minute we have to convert it first second, then this is watt, which is equal to MK system. So we have to write here value N1 which is equal to 1, here 1, clear, not 60. So next M1, L1 and T1. In MK system the base unit which is considered as kilogram, meter and second. So you can write here 1 kg, 1 meter, 1 second. But we have to find here N2 and where M2, L2, T2. We have to find another system of unit, the new system of unit which possesses mass which is equal to 100 gram, length which is equal to 1 centimeter and time equal to 1 second. So we have to write here 100 gram, 100 centimeter, 1 second. This is a new system. New system. We don't have any idea about that system because this is not CGS system. If this is CGS system, then we have to write here 1 gram, 1 centimeter, 1 second. Clear? Okay. Now let's start. N2. So N2 equal to N1, M1 by M2 power A, L1 by L2 power B, T1 by T2 and here power C. But N1 is 1, M1 is here 1 kg. So you can write here 1 kg divided by M2. M2 here 100 gram whose power A is here 1, again L1 is here 1 meter, but L2 100 centimeter and power 2, M1 L2. Okay, next time here 1 second and here also 1 second. So 1 second divided by 1 second and here power minus 3. Clear? Power is here minus 3. So we have to write here kg. Now convert kg into gram. So you can write 1 into kg or 1000 gram divided by 100 gram. Here power 1 meter, 100 centimeter divided by 100 centimeter and power 2 and second cancel 1 minus 3. Clear? Okay. But here we can write gram cancel, centimeter cancel and 20 cancel 10, remaining part 10 into and here cancel, then 1 square and here 10 to the power minus 3, or you can write 1 by 10 to the power plus 3, sorry 1 by 1 3 you can write here. So this is positive sign. Actually numerical value never be negative, so you can write here positive sign here. So this is 1. So here N2 equal to 10. Now we have to write this relation here. Then we can write N2 and here given that 60 joule per minute on a new system, the new system we can write here 60 joule per minute which is equal to another system here N2 equal to 10. You have to write here new system of unit. Clear? So in this way you can solve different type of problem regarding this concept. Now let's start. What are the limitations in dimensional analysis? Clear? Okay. So first we will see limitation of dimension. We already discussed. We have to when we express a physical relation, when we express a physical quantity in terms of various physical quantity, there is one constant quantity and that constant quantity, suppose T equal to K under root L by G. What is K? K is here proportionality constant and that proportionality constant
and its value we cannot find by using dimensional analysis.
So this is the most important limitations of dimensional analysis. That means it is unable to provide the value. First limitation, it is unable to provide the value of a proportionality constant, value of a proportionality constant. That means this constant. So it is unable to provide the value of proportionality constant by using dimension, but you can find its value or dimension, you can find its value by using another experimental method. So this is important limitation of dimensional analysis. And second limitation, we can't find a relation if quantity or a physical quantity depends on more than 3 factor. More than 3 factor. Suppose if you want to find a centripetal force F, and that centripetal force depends on mass, length, suppose mass, radius, velocity, and you can take another physical quantity also here, suppose mass, radius, velocity and acceleration. Here this physical quantity depends on 4 factor, and that by using this dimension we cannot find the physical relation of centripetal force by using 4 factor, because in dimensional analysis we have to use only 3 factor, power A, power B, power C. We cannot find the power D, or we cannot find the value of D is here. Clear? So this is another important limitation of dimensional analysis. And third limitation, we cannot obtain a relation by using trigonometric function or any exponential function or logarithmic function. We cannot obtain a relation by using trigonometric ratio, sin theta, cos theta, tan theta, these are trigonometric ratio, and logarithmic function, exponential function like this. Clear? And next important limitation, suppose if you want to write a relation here, V equal to U plus AT, we already discussed about this relation here, V equal to U plus AT. Actually this is physically correct, and if we use homogeneity principle here, then each term dimension same. Okay, this is dimensionally correct. If you want to write V equal to U minus AT, then in dimensional analysis this relation also dimensionally correct, but this relation is not physically correct. So dimension don't give any idea, it does not give any idea about nature of sign, about the nature of sign. This is negative or this will be positive. Clear? According to dimension, these two relation is dimensionally correct, but this relation is physically not correct. Clear? Okay. And next limitation, if a physical relation is dimensionally correct, if a physical relation is dimensionally correct, it may or may not be physically, if a physical relation is dimensionally correct, it may or may not be physically correct. Clear? And suppose this relation is dimensionally correct, but this relation is physically not correct, and it is the it is a physical, if a physical relation is dimensionally correct, it may or may not be physically correct. And in dimension don't give any idea about this relation. Clear? So these are the limitations of dimensional analysis. So we already discussed the application of dimension analysis. First application to check the correctness of different physical quantity by using principle of homogeneity, and second we derive a physical relation by using a different physical quantity, that means 3 factor, only depends on 3 factor, then we derive a physical relation by using this factor. And next today we discussed third use of dimension, that means conversion of unit, one system of unit to another system of unit, and these are the limitations of dimensional analysis. Clear? So you have to study clearly, and you have to step one by one step, and remember all the things which will help your council examination and any board examination. Clear? Thank you all.